Part 2 starts from here. First example, sodium sulfate. You can see here, this is sodium and we have 2 atoms of sodium. This is sulfur, then we have 1 atom of sulfur. This is oxygen, we have 4 atoms of oxygen. Now let me write the ratio of these elements. This is sodium, then we have sulfur, and then we have oxygen. So this is 2, this is 1, and this is 4. Now you must be thinking that I have told you the concept of no common factor, and here we have a common factor 2 between the sodium atoms and the oxygen atom. So now how I can justify that this is the empirical formula of sodium sulfate? So I would like to tell you here that when I'm taking into consideration the empirical formula, and I'm telling you that the empirical formula of the compound is a formula which shows the simplest whole number ratio, and the simplest whole number ratio represents no common factor. I am taking into consideration that all the atoms of the elements should not have any common factor. Here there is a common factor 2 between 2 and 4, but with sulfur we don't have. So overall, if we consider, we cannot take any common factor among 2, 1 and 4, because 1 will not have any common factor. We cannot take 2 as a common factor here. So in this case, the number of atoms of the sulfur does not bear any common factor with the atoms of the sodium and the oxygen. So we cannot take any common factors. So that means they share no common factor. So this justifies the first condition. The second condition is that these ratios should be positive integers, and they are. So they are positive integers. So these two conditions are justified, so we can consider sodium sulfate, that is 2 atoms of sodium, 1 atom of sulfur, and 4 atoms of oxygen, as the empirical formula of sodium sulfate. Now consider this complex formula. Here, first of all, let me write the ratio of the various elements present. Carbon is to hydrogen is to nitrogen is to oxygen. Carbon has 4 atoms, hydrogen has 8 atoms, nitrogen has 2 atoms, oxygen has 1 atom. So the condition that they bear positive integer is justified. Now the second condition of no common factor, they should not share any common factor. You can see here that there is a common factor among carbon atoms, hydrogen atom, and nitrogen atoms. We can always take out 2 as a common factor. But what about the oxygen? Oxygen doesn't have a common factor 2. So in this case also, as oxygen atom does not have a common factor like carbon, hydrogen, and nitrogen atoms, so we cannot take any common factor on a whole. So if we take the overall ratio into consideration, we cannot take any common factor. That means the ratio of the atoms of various elements present in this compound have no common factor. So that means we cannot convert this formula into more simpler ratio. So this formula represents the simplest whole number ratio. Thus this represents the empirical formula of this compound. So all you have to remember is just you have to consider 2 conditions, that is no common factor and positive integers. So this one is the most important of one, no common factors. So if there are no common factors, so that means there's atoms of elements bears a simple whole number ratio, and if they bear the simple whole number ratio, that formula represents the empirical formula. Methods of determination of empirical formula. Empirical formula can be determined by 2 methods. First, common factor method, and second is the percentage method. These 2 methods have been discussed with examples in other videos. So that was all about the introduction to the empirical formula. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com. Have a great day.